Well, like at one point, like Mr. Olson was like, oh.
You should just bring him in, like one of these days, just because we want him in.
Well, Mr. Olson was like, he's like, the stuff we're learning, like they're doing in there, they could really come and see you. And I was like, oh, you guys can come see me. And then they never did. So I don't know.
They hate you.
They're bad people.
I'm gonna ask them that.
Every once in a while, Callie and John would come and like review with me and then take their test, or like one day they missed or the video wasn't working and I just taught them the lesson, like just the two of them.
Because you have like prep their period, right?
Second, yeah, and that's when they do this class. Sawyer does it third, so he, I don't have prep then, so. It definitely is not an ideal. I would not recommend taking an AP class and pre-calc at the same time.
Or taking online classes.
Yeah, I know. You did, because you did online algebra too,
Yeah,
right?
That was not fun.
But I don't feel like you, like, I feel like you did well enough that, like, you did, like, it wasn't like you.
It wasn't that bad. It was just, I would have much rather been, like, with
Yeah.
a teacher.
Yeah. I just don't think many people would have been able to pull, I mean, the fact you're doing fine in here shows that you pulled it off well enough. I never stamped you guys. You guys all have it done. How do you like it?
I have it done.
I have it done.
Matthew doesn't have it done.
There is the backside by mistake.
What?
I
You did
also
the
did the
backside?
backside
Oh,
as-
you overachiever.
There is no backside.
He's making jokes over there. He's got jokes.
Yeah. Here's a backside.
Does this make sense? Karen's done. I learned from Tara. I think I do learn from Tara. Was that your spring supplement there? Someone left to be behind from one of the classes. Did you write I'm stupid and spelled stupid right?
No, I was writing upside down. It's okay.
It kind of is funny though.
Yo, we got a lollipop.
It's supposed to be a cherry.
Oh, mine's upside down. Mine's
So
upside
what kind
down.
of lollipops are you eating?
Turn it upside down. It looks like a lollipop.
No, it doesn't. Snake is a never like that.
Why not?
Because it's not like a cane.
It would be like, that's like when the stick gets all soggy or something.
Well, what about those sticks that like loop? And
Oh,
then,
the
like,
loop
what,
ones.
like,
Those
cut?
safety ones that the kids aren't supposed to be able to choke on.
That you get from the doctor. Those actually are really good.
Basketball
I feel like those ones used to cut my tongue, like they'd be like so sharp on the edge or something.
Really?
Maybe they got better. You guys have one.
I don't know how I got Baja on my phone. Just one.
All right, so this one okay? Yeah.
Just give your hands.
All right. So
You can.
let me get you guys what we're doing today. So this is our last day of new notes before getting ready for the exam. And looking back, I really wish I would have done this in the section it was in chapter 4, this modular arithmetic we're doing today. I really wish I would have done it back in that section. It just was one that, like, we were kind of close on time before exams, and Mr. Heffernan told me it'd be okay to skip it. And it is okay. I mean, you don't necessarily need it. I actually never learned this when I was in pre-calc, but it really goes well with that chapter, so it might seem a little more disjointed than I would have liked. So. Yeah.
Well, maybe I should.
And I actually put the warm-ups on here for those of you guys who were gone yesterday. Sounds like most of you guys were okay, but I don't think Sam got the material lesson, so we'll go through things a little bit.
I took way too much away from that lesson.
base 10 is, it's probably worth, when you're working with base 10, I like having like kind of the chart written out, like the different powers of, with base 2. So like kind of have it written out as 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. And I basically have to go as high as my, my number. So, looking over at this, so it's 1 because there's a 1 there. Then it's not 2, but then it's also 4 because there's a 4 in that slot. Then we skip 3 slots, and then we go 64. Oh, great. Why did that happen? Right? Am I right about the number? Great.
Say a funny number.
Yeah.
Funny number.
Oh boy, of course. And that was honestly me just like putting digits together, not planning any. That's why you have to plan things as a math teacher. This is so stressful. And I absolutely failed. All right, anyway.
Hey, you just do what you want to use together.
Yeah, great.
Funny number.
Okay, so 175, I start with a 128 because that digit is necessary, so 1. But then I subtract 128 from 175 and I get 47, so I get to skip this one. But then, so that means I needed one at the 32, so then I take 32 away from 47. And I'm at 15, so I get to skip the 16. 1, so I'm at 8. I go down to 7, so I take that 8 away, I'm at 7, so that means I'm going to use the 4, the 2, and the 1. Is that what I need to do? I think so. Alright, so the warm-up, these two were meant to help those guys review that weren't here, just to make sure you guys are on kind of the same page with us. Remind me to change my notes for next year. But and then these imaginary numbers, though, that kind of gets thrown kind of out of the blue. Like that seems like we haven't talked about that for a long time. But I thought it was good to look at those because those really are similar to what we're talking about today. Is the fact that there's a pattern with the eyes, that it has a pattern of 4. So that once we get to the 4th value, that pattern repeats again, and that's essentially what we're going to be talking about with this modular arithmetic. So if you guys recall, we talked about the I values, and it's probably good to review this anyhow coming into our exams. So we have I to the 1st, I to the 2nd, I to the 3rd, I to the 4th, and then this pattern repeats. So depending on kind of where we're in that pattern, that allows us to figure out some of these bigger numbers. So I to the 1st is just I to the 2nd is -1, I to the 3rd, we learned that was -I, and then I to the 4th is going to be just +1. And again, with that, we got to put those out there like in terms of multiplying i's together and just knowing properties of I. So if you forgot why that was, it basically is that I'm multiplying 4 i's together, and 2 of them are -1, so 2 negatives multiplied together is +1. So I to the 4th power is +1. Then we have I to the 24th power. Any idea what that would be? We talked about this, I think, a few chapters ago. 14, not 24. Oh my gosh, go back to that down here. Like, seriously. 14, 24 would be nice. But, so let's talk about 24. That might be a good way to start. What would I to the 24th be? Any ideas?
1.
That would be 1, because it's a multiple of 4. So I guess in my head that's what I was thinking. But I to the 14th is not a multiple of 4, so it's somewhere in between that. Any ideas on how to figure that out? What'd you do? Yeah.
What are the closest multiple of 4 and then subtract what's left and maximize it?
Yeah, so what you're kind of doing when you're subtracting what's left, you're kind of finding a remainder. So like how far away from that multiple of 4 are we? So the closest multiple of 4, you went to 12. And then so we're 2 away from that. So 12, we'd be 2 more from there, right? So this would be I to the 12th would be here, I13, I14. So this would be -1. So what she essentially did was she kind of found a remainder. She basically said 14 divided by 4, the whole number is 12, and then it's a remainder of 2. And when we had done this, we had written this out, we called that like a remainder theorem, that 12 times, or not 12, sorry, gosh you guys, holy cow, oh, no, that's 3. Back one more, sorry.
See a break.
Yes, seriously. 3, and it's remainder of 2. And where this came from was 4 times 3, and then plus 2. This is our remainder. That was the way we wrote that. That was called that remainder theorem, is basically showing how we got those 2 numbers, and then that was a remainder. And so that would tell me that to count 2 more places down. That's essentially what we're going to be talking about with this modular arithmetic. And again, it would have fit a lot more nicely if we had done it like with that chapter. So again, I'm kind of, first time going through teaching out of this book, I'm a little disappointed I didn't do it then. So we're looking for basically the remainder, or kind of what's left over with these. So we're going to break down into factors and remainders. So we would read this as n mod p is the way that looks. And basically what that's saying is I want to figure out like what the remainder would be is if I'm dividing n by p, like kind of what's the leftover. So I want the remainder . And now I don't know why they do this, because I guess because it's not technically an equation, is they have a triple equal sign there, but like 3 equal lines, and that's because of the fact that, again, this isn't necessarily an equation. 15 mod 4 isn't really like a math operation. It's saying what's 15 divided by 4, and then what's our remainder then? So like what's the leftovers? So I like the way Maria explained it. She said, basically you find the closest factor and then kind of count or subtract until you get to that other value. Now when they start to get to be bigger numbers, they get a little bit trickier to do, like using a calculator by hand, and kind of have to think about that. So, if you're thinking about this one, hopefully you're thinking through your factors, and depending on, so like 4 times 3 is 12, and then to get to 15, that would be 3. So this is what the 15 mod 4 would be. And like when I was like looking online about this, I even found like modular calculators. So there's calculators that do just this. Like there obviously must be some sort of more of an application for it, but I'm not super aware of what that is. But it's just like we're looking for that leftover there. So 152 divided by 5. So this one's a little bit trickier. This one you might have to play around with your calculator a little bit. A lot of times what I do is I do 152 divided by 5, and I see it's 30.4. So then I say, well, 30 times 5 is 150. So then my remainder then is just going to be 2.
Wait, we were supposed to do actual division. We were supposed to do.
You could do it that way. Yeah, so actually what Cash is doing is he did long division. So he's doing 152 divided by 5, and he says, well, that goes in 3, 15, and then 0, 2, it doesn't go in at all, so this is our remainder. Yeah, that works as well, and just like, it's whether or not you want to do that, or like, especially if we're getting to like 2-digit numbers, divided into it, you might not choose to want to do that. So the mod is just like figuring out that remainder. If you guys want to try these next couple, and again, so like on example 4, like I would not choose to do that by hand, but it's up to you if you'd like to. Dividing a 4-digit number by a 2-digit number, I think it's easier just to use my calculator, but.
She said goes.
Yeah, she said goes. That's kind of messed up.
What did she say she has?
I asked her, she said she's coming.
Oh.
And I said, why? And then she said, cuz.
Oh.
Like, I was like, why are you late? And she was, cuz.
She's gonna walk in here with like children.
Maybe she's bringing us all donuts.
So you can eat them in the
Now, will you guys be picky about if I do show up with donuts? I feel like now I have to because I've been discussing it. If should I bring the kind that I think are the best donuts, and you guys can make a decision?
Bring a variety.
A variety. You'd
Well,
rather
actually,
have a
I don't
variety.
even have a say.
Bring like a whole flat.
Well, I'm wondering though, like I feel like you guys have to try the ones that we called Heaven Donuts. Like,
Yeah.
you need to try the Heaven Donuts.
Bro.
All right. I know there's a lot on the back. I don't know if we'll get through all those, but we'll see. That looked a lot worse when it came off the printer. I was like, wow, that looks like a lot of problems. Sorry. All right, the next couple here are true or false questions. So it's kind of strange to think, like initially when I looked at these, 'cause like again, I'm not really super comfortable with this mod thing. I hadn't seen that notation really much before. And so looking at this, I was kind of like, well, how could 139 and 59 both have the same remainder? Are those two equal or equivalent in terms of their mod if the mod is 10 for each of them? Basically, they're asking, is the remainder the same for each? So you're just finding the remainder for each one and then checking if they're the same. So I'm doing 139 divided by 10. So obviously 13 times 10 would be 130, so our remainder would be 9. And then 59, or sorry, 5 times 10 would be 50, so our remainder is 9. So this one is true. So you're checking to see are they true or false, so you're just basically checking the remainders for each of them. So give you guys a minute to try those. So on 139 mod 9 and then 1 like just looking at that quickly, I would think that those aren't equal because they're so similar, like they're similar to that last one. So this is gonna be 15 times 9. So 135, so this one's 4. So this would be 6 times 9. So that's gonna be 54, so that's gonna be 5, right? So this is 54. So this one is false. So we get 136 here, so this is 3. This is 56, so that's also 3, so this one is true. Now, one of the things I like an application of this is one that I've seen on like a test like the ACT. I've seen a question like this before, or maybe more than once, that it comes up in my head a lot, is essentially being able to figure out the repeating decimals and like, you know, if I wanted to know the 5th decimal place or the 500th decimal place, I should be able to do that. And essentially it's kind of the idea that we did with the eyes, but also with this mod idea. So if this is a repeating decimal, 0.428 keeps repeating. So this would be 0.428, 428, and keep going on like that. So if I want to figure out the 5th decimal place, obviously I can just count over. The 5th decimal place would be a 2, so I'd be able to tell that. However, I don't want to do that to the 65th place, and I definitely don't want to do that to the 500th place. And I have to like, basically, I feel like I need to tell Cash, you better not do that to the 500th place, right? So please don't go that far. But what we want to think about is how I can use kind of this idea with the repeating, like kind of like we did with the eye, except this time it repeats only how many times? 3. So the I was repeated 4 times. This time it's only repeating 3. So I'm going to take, so this is basically talking about like 65 mod 3. So I'm going to take 65 and divide by 3 to figure out what part of the pattern I'm in. So like 63 would be the closest factor. So I'm 2 away from that. So the idea is if it's mod 3, the 3rd place is like the factors of 3. So 8 would be the factor of 3. So if I'm 2 away from that, I have to repeat my cycle. So 1, 2. So this would be 2. So the 65th decimal place would also be a 2. And I think 500 might be the same. Is it the same? Because 166 times 3 is 498. So strangely enough, all the ones we've chose, I don't know if it's because they're, hi, I missed you.
Yeah.
We said maybe you were picking up
Sure
donuts for
donuts.
us, yeah.
Yeah, where's the donuts?
Not here for you. Maybe I brought some for the other people. Not here.
Where are they?
Up your butt.
Wow, that's so nice. Those.
What did I do?
Wait, how did you first answer the?
Alright. We don't need to stop.
We should have I should have like a card that tells like the two of you Cash. Stone to not. Stop listening to Stone right now, Cash.
Yeah.
Stone.
It was Becca. I didn't even say anything. All I said was where are the donuts?
And this is like in your
Alright.
butt.
Okay.
Anal cavity.
Oh my God, no Cash, no. Remember the day when Cash said anal cavity? Stone or Becca started it. So, all right.
Yeah, this is your fault. This does so.
Sorry.
No, it's okay. So going down, you can add, subtract, and multiply modular integers. So sometimes adding them together or adding them separately is going to be helpful. So if I just take the two mods, I can add them together. Otherwise, I can also add them first and then do mod of p. So you can either do one or the other or both. They should be the same. So sometimes adding them together you'll notice is helpful, and then sometimes keeping them apart will be helpful depending on the situation. Subtraction works the same way. Which I guess, in my opinion, is a little bit strange that you can kind of do them independently or at the same time, because there's not like an order of operations with them.
Wait,
This should be a times
why
here.
did you put the brackets in that?
Oh, they use brackets in their notation for whatever reason.
Oh, okay.
Wouldn't that aesthetically like
Yeah. Oh, like the whole board would fall off, or like my computer fell off there.
Yeah, and then it's.
I'm actually shocked that doesn't happen because I'm such a klutz, and that's typical of me. But like, yeah, I'm shocked that doesn't happen all the time.
What would the school say? I'm your whole
Well,
board
this
fell
one
off.
is mine, so that one would be my
The
fault.
board.
That would be really bad. Like, I would be probably crying when I had to go tell someone that happened. Seriously. The waterworks would start like immediately.
They come in and like it's just on the ground.
And I'm just sitting here crying.
With like us just sitting here like,
Yeah, like, we don't know what to do with her. She's having a meltdown.
I can't even go.
All right.
Wisconsin versus Northwestern.
Oh.
All right, so again, you can do one or the other or separately. So I just want to kind of show you guys that they're the same either way. So we could do 11 mod 3 and then just add it to 8 mod 3. Or I could do 11 plus 8 is 19. They should give me the same thing, and Becca will show you guys I'll show you how this works. So basically this is that we're dividing 19 by 3. So most of the time I think adding them first makes more sense unless you notice something really obvious, like maybe that it's like a multiple or something, but then it would add and be the same. But so 19 mod 3, I divide 19 by 3. The closest factor is 18. So 6 times 3 would be my closest factor is 18. So 18 is 1 away from 19, so that's what this is going to be. So it's just asking for the remainder. It's just another notation for that.
Is it always mod 3?
No.
No, yeah, all of these are examples. So like if you look up a bar on the other side, so this is, yeah, then you would divide by 17 instead.
Okay.
I just stuck with the same thing on these. So 11 minus 8 mod 3. So in my opinion, this would be 3 mod 3. Oh, so this is a good example where I think doing this would be easier. So when you divide 3 by 3, it's obviously there's no remainder. So this would just be 0. So doing them separately would kind of be a pain because you'd find out that, oh, it just ended up being 0. Because 11 mod 3 would be 2, and then 8 mod 3 would also be 2. So I just subtract them. Now, when we get into negatives, and that's I guess maybe that's part of why I like this lead into this. I think negative with the mods is really confusing. So I'm going to actually, I think subtracting them in this case might be helpful for us to understand what's going on here. So I'm going to do 7 mod 3, and then I'm going to subtract 19 mod 3. Again, I think negatives with these modular arithmetic, I think it's confusing. Like it's hard for me to wrap my mind around. So 7 mod 3 is going to be, the closest is 6, so this is 1. Oh, this ends up being 0. Shoot, it's not a good example. Oh, because that's, well, it still might be worth talking about. 19 mod 3 is also going to be 1. So this is going to be 0 because 7 minus 19 is negative 12 mod 3. And 3 goes into negative 12, so that's why its remainder is 0. That's probably not what I was intended, but. All right, so again, here we have 88 mod 3. And so I don't know, maybe like the smaller numbers you might decide, and that is a multiplication, again, for whatever reason. I don't know if that was just Mr. Hatfield's notation or this book's notation, but they used the little asterisks instead. So the closest is 87. Oops. And so this will just be 1 here.
See, there's some use of binary here because 1, 0, 0, 1.
Oh yeah, there you go, binary again. Great.
That would be 9.
All right. So the negatives are a little bit trickier, and so that's what we'll talk about now. Is with negatives, you actually are supposed to go. So with positives, we stayed under the value and then counted up to our remainder. Negatives, we want to go kind of more negative. So if I want to think about the closest factor, or the closest multiple here, I'm going to use negative 12 instead, if that makes sense. So I'm going to do 3 times negative 4 is a negative 12. How do I get back to 11? By 1. So I want this to be like a positive, like how far away from it I am. So I'm actually going to go over on this one, which technically is under, but just thinking about negatives is the negatives are actually smaller numbers. So I'm going to do 6 times negative 4. So a negative 24. How do I get back to 20? Positive 4. Now this one throws me off. This one's a tough one for me because it's negative 3 and then the mod 11, it doesn't go into that. So
Wouldn't it just be 1? Just like multiply by 1.
maybe 1.
Oh, well, like, wouldn't it be 8? Like the,
It'd be 8, yeah, no.
I mean, like,
yeah.
multiply.
Yeah, oh, that's a good way to think about it. I guess I didn't have a good way to explain it. So he's saying like try, yeah, so like multiplying negative 3 times 1.
No, I did 11 times 1.
11 times 1, and then how'd you do?
Because then it'd be negative 11.
And then
the
to get back
difference
up,
is 8.
oh. So he did 11 times negative 1 is a negative 11 to get back up to negative 3 and be 8. The way I thought of it was just basically how would I get up to a factor that would make sense. So I would need to go up that much, but no, I like what you did instead. So basically we go down, further down past negative 3. The closest factor would be negative 11, and then to get back up. Those ones are really tough for me to wrap my mind around. And when I talked to Mr. Hatfield about this one, he's like, this is a cute one. And I was like, you call that cute? Like, I mean, like that's when I say something's like math fun and not like regular people fun. He calls it cute. I would say that it's not cute, but you know, like, so just kind of these negatives are a little bit strange as we do these.